Good morning, scholars. Hope you guys are doing well. Yesterday with Miss Bab, we started working on box plots, and today we're going to do just a little bit more in understanding them. Go ahead and take a second to write down your title and your objective. You can't quite see the whole thing. Okay, so what I've drawn here is a box plot. This might also be called a box and whiskers plot. Just write that in up here. Box and whiskers plot. This bit right here, the rectangular bit, this is called the box, and then these lines that go out are called the whiskers. I don't know what I just wrote here. Box and whiskers. I meant to write plot. Wow. Anyways, okay, so the first thing that we're going to do is we're going to finish labeling this number line, just like we did with our axes, with our x and y axes. So we know that 30 to 40, so that's a jump of 10. So these little guys in here must represent numbers in between 30 and 40. But what are we counting by exactly? Well, let's see how many spaces there are here. Starting from the 30, we have 1, 2, 3, 4, 5 jumps to get to 40. So that means we want to section this out or divide this space in here by 5. So this is, there's 10 in between 30 and 40, right? 40 minus 30 is 10. And then we divide that by the number of jumps, which was 5. That gives us 2. So that means that each of these is counting by 2. So we're going to go ahead and label those in. Okay, so in this whole thing, we're always counting by 2s. Etc. So I recommend that you fill these in. You're not always going to see a box plot that is counting by 2s. So be careful that you are labeling it correctly. And you'll see why this is important in a minute. We're just going to talk about definitions really quickly, and then we'll ask ourselves a couple of questions. So each of these vertical lines here, part of the plot, those are the important lines. So this guy right here, we call this the minimum. That's a minimum value. The minimum, or the min for short. This right here is Q1, or quartile 1. This line right here is the median. This line over here, the next vertical line, we call that Q3. And finally, this line right here is the max. So if you wanted to really quick just label what the values are of each of these 5 words, let's do that right here, the minimum. So this line, we can see it lines up with the 32. That's why I went ahead and labeled all of the numbers on my number line. So the min would just be 32. Q1, let's see where that value lines up, 38. The median lines up with 46. Q3 gives us 60. And then the maximum number in the data set would be 66. Okay, so the minimum number in our data set is 32, the maximum is 66. The rest are somewhere in between. Now let's ask ourselves a couple of questions. What is the range? Well, we can find the range of this, and you're going to see all the practice problems today are on Delta Math. There's no exit ticket or anything like that. So these are the types of problems you're going to see on Delta Math. What is the range? The range is simply the max minus the min. So let's look over here at what we found. We found that the max was 66. And we know that the min is 32. So we go ahead and figure out what is 66 minus 32. 34. So that's the range. Again, that was just the maximum minus the minimum. What is the upper quartile? Upper quartile is just another way that we name the Q3. So over here where it says Q3, I'm just going to give ourselves a little reminder. We can also call this the upper quartile. It's the larger of the 2 quartiles that we have here, Q1 and Q3. Here's an interesting question. What percentage of the data values are greater than 46? So let's go back up here. In between each of these guys that we've labeled, 25% of the values go in between each of them. So let me change colors. So 25% of our numbers in our data set are somewhere in between 32 and 38. Another 25% are in between Q1 and the median, so that would be between 38 and 46. Another 25% are in this area right here, all the way from 46 to 60. And then another 25% go from Q3 to max, which is 60 to 66. So as you can see, 25% go in each of these sections. Now there's 4 sections of 25%, which would give us a total of 100%. So let's look down here. It says, what percentage is greater than 46? So let's find 46 right here. Okay. So what percentage is greater than 46? You can see we have 2 sections here. We have this section, and each section is worth 25%. So if this is a 25% section right here, this from here all the way to here is 25%. And here's another 25% section. All we're going to do is add those 2 sections together. So we have 25% plus 25%. That gives us a total of 50%. Okay, so that's our answer to that question. Okay, just 2 more questions. What is the second quartile? That's just another name for median. So again, over here where I kind of have been storing the other names, the median, we could also call this Q2 or the second quartile. Now that kind of makes sense because we have a Q1 and a Q3, so the line in between would make sense to be Q2. That's just another name for it. So the question is actually asking, what is the second quartile? So let's find the actual number, 46. That's my answer there. Oh, looks like I forgot to answer the upper quartile. So we talked about how upper quartile was Q3, so let's look at the actual number, 60. All right, last question. What percentage of the data values are less than 38? So again, we'll find 38 right here. Less than goes in the left-hand direction, so you can see that we're looking at just one of our 25% sections. Again, each of these green sections was 25%. I didn't label them all, but here we go. So less than 38 would be just this one section right here. So one section of 25 would just simply be 25%. Okay, just a quick note before we end the video. I just want you to realize that the number line could look different, and so could the box plot. So you're going to see your problems on Delta Math. So for instance, your number line, you know, it could be counting by ones. It could say 1, 2, 3, 4, etc. And you can see with this box plot, our box was pretty long and then the whiskers were pretty short. Well, it could look something instead. We could have a shorter box, right? And then longer whiskers. But the same names apply, again, where we are looking out for those vertical lines, right? Minimum, Q1, median, Q3, and maximum, those lines right there. And again, in between those lines is still our 25% section. So even though these sections are not equal to one another, right? Some are smaller and some are larger. So we're not trying to do like pieces of a pie, fraction type things. We're just saying that 25% of the numbers are going to be in this range, 25% will be in this range, 25% will be in this range, and 25% will be in that range right there. Again, each divided by the 1, 2, 3, 4, 5 vertical lines that appear in your box plot. All right, so go ahead and go straight to Delta Math. You've got just 10 problems to do today, no exit ticket. Good luck. Feel free to call or text or FaceTime or Zoom or however to get in contact with us. Have a great day.